What is happening, guys, and welcome back to Redbeard's Garage. On today's video, we're going to be turning a 440cc Duro Max engine into a go-kart animal. We're going to be using Go Power Sports parts, and make sure to check out the video's links if you're interested in any part or tool used in today's video. They're all linked down there, and those do help us to continue to do these videos. Without further ado, guys, let's jump right into it, tear this engine apart, and it should make around 30 horsepower and 40 foot-pounds of torque when we're done with it, which is insane to be on a small go-kart, and we're going to build it up to even more power in later videos. So make sure to stay tuned in and let's get this thing built. First, we need to remove the evap box, air box, carb, muffler, and fuel tank. Now we can remove the throttle bracket, governor arm, fan shroud, and coil. Remove the starter and the oil sensor box. Remove the flywheel nut and remove the starter cup and the fan. To remove the flywheel, thread the nut back on, pry outward on the flywheel while hitting the crankshaft end with a hammer. Remove the charging coil and wire retainer. Next, remove the valve cover, rockers, and push rods before removing the head. Remove the side cover, balance shaft, cam, and cam tappets. Take off the rod cap and slide out the piston. Now we can remove the crankshaft, oil sensor, and governor arm from the block. Remember, all the tools and parts are linked in the video's description that we used on this engine. On this build, we'll be using a billet flywheel with the starter ring gear for strength and safety. The billet rod will give the engine a longer life and higher RPMs. The 34mm Mikuni will provide more flow with a better throttle response. This 308 cam will produce more power throughout the power band and will allow the engine to rev even higher. For our valve train, we'll be using 65-pound double valve springs and cut-to-length chromoly push rods. We'll also be using a set of 1.2 ratio rockers. This head has been milled 70 thousandths and ported. We need to tap the oil sensor and governor hose on our block. For the governor hole, we will be installing a hose bar to help vent the crankcase pressure. I will not be keeping the balance shaft in this engine, so we need to remove the bearing in the back of the block. I use a homemade slide hammer and weld it to the bearing. Make sure to cover the cylinder sleeve so spatter doesn't stick to the board. Before installing the billet rod, we need to test our oil clearance. Place the rod in a vise with a glove or soft jaws to protect it. Remove the rod bolts and cap. Install the rod bearing, making sure to line up the oil hose and notches. We can now place the crankshaft onto the rod. Use red Plastigauge to test our oil clearance. Cut a 5/16 inch piece of Plastigauge and place onto the rod journal. Now install the rod cap with the oil dipper on the longer side of the rod. Place a small amount of oil on the bolts and torque down to 26 foot-pounds. Start at 16 foot-pounds while alternating between bolts, adding 4 foot-pounds until reaching 26 foot-pounds. Once torqued, you can remove the rod cap and measure the Plastigauge. We are shooting for 3 thousandths with no less than 2 thousandths and no greater than 4 thousandths clearance. Our test shows 2 thousandths of an inch, so we're good to proceed. Make sure to scrape the Plastigauge off the bearing in the crank before installing. We need to install the ring into the block to check our ring gap. Use the piston to slide the ring about 1 inch into the cylinder. Ring gap is important in an engine because if a ring expands too much, it needs the room so it won't bump into each other and score up your cylinder walls. You don't want too much of ring gap because that will allow compression to leak past the rings. Check the ring gap with a feeler gauge to find out the gap. If installing an aftermarket piston, check the manufacturer's requirement for ring gap. On screen is the Wiseco chart that comes with Wiseco pistons. This is a good general ring gap diagram to use on any of these small engines. We're going to be using a mechanical ring grinding tool. Always grind your ring gap from outside to in. Take off small amounts and recheck often to get the required gap. Make sure your edges are straight by squeezing the ring together to check for an even surface. Lightly file off any burrs off the edges of the piston ring before installing. To find out your bore size, use a set of telescoping gauges and calipers. Now that our ring gap is set, we can install our piston rings back onto the piston. There are 5 rings total: first compression, second compression, spacer, and oil scrapers. Install the scraper first, next install the oil rings on top and bottom of the spacer. Install the second compression ring, then the top ring with the letters or numbers facing up. The second compression ring has a black face to it and the top compression ring has a chrome face. Make sure to space your piston rings 120 degrees apart. Now we can install our rod. The arrow on the piston points down when installed. Make sure to place the longer ear of the rod facing down with the arrows when installed. Oil the rod, wrist pin, and piston before installing the rod. Slide the wrist pin in and install the wrist pin clip. Use a small set of pliers to start the pin in the piston and then snap it into place with a pick. We can now start our assembly. Slide the crank back into the block. Oil the cylinder and the ring compressor when installing. Make sure the ring compressor is seated against the block and tap the piston in. Oil the rod bearing and install the rod cap using the torque method as before. You can see this small windage tray is in our way of our rod bolts. You can break this off with a set of pliers or use a Dremel to remove this. Install the cam followers and cam by lining up the dots on the cam and the crankshaft. Remove the governor gear by tapping out the pressed in pin. Since we are not using the balance shaft, we need to also remove the bearing and the side cover as well. Block off the hole with a little bit of high temp RTV. Place the dowels into the block and install the side cover. Once the side cover is torqued, we can see we have too much end plate. Linked in the description are Crankshaft Shims. Our engine used 2 thicks and 1 thin shim to get our 10,000ths end plate. We need to remove the flywheel key and lap our new flywheel. Place valve grinding compound onto the crankshaft end and spin the flywheel onto the crankshaft to mate the surfaces. Make sure to clean off all the compound when finished. Install the starter before installing the flywheel. Then install the flywheel key, flywheel starter cup, and torque to 85 foot-pounds. I use an old CVT pulley from a 40 series to keep the crankshaft from moving while torquing down. We can now dress out our head. This simple tool makes installing the caps a lot easier on non-Hemi heads. If building a Hemi head, you will need to use the spring compressor linked in the video's description. Install the dowels and the head gasket and torque the head to 26 foot-pounds. Since we are using ratio rockers, we need to remove the studs and the guide. To find our pushrod length, I'm using adjustable pushrods. Start off by setting my adjustable pushrods to stock length and then installing the rockers. Paint the lash cap with a dry erase marker to see where the rocker is making contact. Our goal is to make the contact point dead center of the lash cap or the end of the valve. Refer to your instructions on your ratio rockers. Now that we know our pushrod length, we can cut our chromoly pushrod to length using the chop saw. Make sure to deburr the inside and outside of the pushrod after cutting and use a press to install the ends. We can now set our valve lash to 3/1000 with the piston at top dead center. Make sure when setting the exhaust lash the compression release isn't on. While spinning over the engine, you'll see the exhaust valve open, then the intake, and then the exhaust will crack open again slightly. This is a compression release cycle. Setting valve lash with this open can cause low compression and kickbacks when pull starting. Pull the valve train and install the valve cover and spark plug. Next, we can install our ignition coil and set the gap to 45 thousandths by placing a feeler gauge between the magnet and the coil. Once set, we can install our intake carb and fan shroud. We decided to run a 34mm flat slide Mikuni instead of a round slide. To break this engine in, I use Lucas high zinc additive with Napa brand 1030 oil. Once broken, I'll use the zinc additive in 1030 synthetic. We had to swap out our starter for a genuine Honda starter which has a longer throw, and it was required on our build to reach the flywheel gear. Thank you so much for watching, guys. This engine is a freaking animal. It revs to around 8,000 RPMs, and it was actually moving our 2,200 pound fab table from Quantum Machinery Group. It was vibrating it around the floor, so pretty crazy. These crankshafts aren't balanced for this kind of RPM, so you're going to get some vibrations out of it, but later we are going to be putting a billet stroker crank and rod into it, a billet side cover, as well as a big valve head. So stay tuned. This engine is going to get even crazier. We're going to shoot for around the 50 horsepower mark out of this engine in the long run, so definitely stay tuned and check out the links in the video's description. They do help us. Go Power Sports has all the parts you can make this 440 into a hoss, and make sure to also look out in the description for a discount code. They come and go here on the channel for Duro Max engines, but when they are available, you can buy a Duromax 440 for cheaper than you can buy a Harbor Freight 420. We've had absolutely no problems out of these engines. We love them and stand behind them. So yeah, guys, thank you so much for watching. We love you, and God bless.